All right, a reflection is a transformation in which a geometric figure is reflected or flipped across a line. Remember from last week, when we talk about reflections, we should think about a mirror, and we should think about the word flip. That is definitely going to come in handy today when we're talking about this page protector and how we're moving it. Okay, a lot of people, when they do this, they want to turn it. Are we turning when we reflect?
No.
No, what are we doing? We're flipping. So we actually need to flip the paper, not turn it. Okay, and I will explain what I'm talking about in a little while. So this is how it works. A reflection moves all points in a figure by reflecting them across L as if L were a mirror. The line L is called the line of reflection. So that line L is called the line of reflection. All right, everybody good on that? Okay, let's look at example 1. Reflect line AB over the x-axis. So what I'm going to do is I'm going to start off, I'm going to highlight the x-axis. I want you to do the same. On your paper, you are going to highlight the x-axis. Okay? So now that I have my x-axis highlighted, what I want you to do is, using your page protector and your expo marker, you are going to trace over the x-axis, the y-axis, point A and point B. And you're going to make sure to label all of those things. So when you do this, okay, you are going to, yours should be just as small as your graph, okay? So, I'm going to show you what I mean by that. So, that's why I told you earlier you did not need a full page protector, right? You only needed a piece. So if your coordinate plane is this big, that's how big your coordinate plane should be on your page protector. Do we understand? Okay. Because what I'm about to come do, it's not going to look that way. Okay? So, if this is my paper, does everybody see that? I'm going to trace. This one doesn't work.
Are we going in the center? Are we going to put our corner plane off in the side?
So, let's watch. I'm going to trace my X. I'm going to label it X. I'm going to trace my Y. I'm going to label it Y. I am then going to put a point for B. I'm going to put a point for A. Does everybody see how I did that? Yes. Make sure you have your points and you have to draw the lines. Can't be lazy. Draw the lines. Exactly what you see. No, the lines. Yeah. Have to draw the lines. Just the axis, the X and the Y axis, have to draw. Okay? So, once you do that, on your page protector, what you're going to do is you're going to take your page protector So I have it here, right? Should be able to line it up. Let me make this so y'all can see a little bit better. Okay, everybody can see that now? You're gonna take your page protector and flip it over the highlighted line. So, I'm actually gonna take my page protector and flip it to where it falls over that highlighted line. Does everybody see what happened to my figure? You line back up your x-axis and your y-axis. What else lined up besides your x and your y? B. B lined up. The only thing that really changed was what? A. Where is A at now? The third quadrant. It is at 1, 2, -3, -2. So then I would pick my page protector up. I would put a point at -3, -2. I would mark that point A. Okay?
On our like sheet of paper or
On your own sheet of paper, yes. You're going to pick it up, mark that point at -3, -2. That would be your A prime. Your B prime, we said stayed the what?
Same.
Stayed the same.
So it'd be 2, 0. Wait, no. Yeah.
So this would be 2, 0 for B prime. A prime we said was -3, -2. So if I look at just the coordinates of A, forget about B right now, look at just A, what do you notice?
equal.
That 2 just went to negative.
The 2 went to a negative. The only thing that changed is the Y coordinate. So when I reflect over the x-axis, the Y value changes. Okay? Now, why didn't B change?
Because it's on the x-axis.
Because it's on the x-axis. X-axis. So it's going to remain the same. Now, I'm going to show you another way that this could have been done.
Can we erase our sheet of
You
paper?
can erase your page protector, but I want you to watch me first. So everybody watch. So do you see how I highlighted the x-axis?
Mhm.
What I can do is I can start at the x-axis and I can say A was 1, 2 away from the x-axis at the top. So A prime needs to be 1, 2 away from the x-axis at the bottom. Do you see how I ended up there? The same distance from the line of reflection. B still would remain the same because it's on the line of reflection. Okay, so my reflection rule here will be the Y value becomes opposite. So I'm going to write that as X negative Y, or X opposite Y. Okay, so the reflection rule for x-axis, well, Y value becomes opposite. Okay, let's look at number 2. Everybody go to number 1 so far? If you're kind of confused, it's okay. Let's do another one and see what happens. Okay, let's look at number 2. Reflect figure CDE over the Y axis. Okay, so I'm going to reflect it over the Y axis. How do I want to start? What do I want to do to the Y axis? I want to highlight it. Highlighting the Y axis. What point's going to stay the same?
C.
C. Why does C stay the same?
And it's on the y-axis.
Because it's on the y-axis. So over here for C prime, I'm going to go ahead and put 0, 2. Okay, what I want you to do, go ahead on your page protector, draw your X and Y axis, draw or plot your points, C, D, and E. And then go ahead and flip your page protector over that y-axis.
Draw the lines, Clark?
I'm sorry, what
You
was
have to
that?
draw lines.
Yep, you have to draw your X and your Y.
No,
Your X
I'm
and your Y is
talking
always
To
important.
connect to,
You don't have to if you don't want, as long as you know your points are correct.
And then butterfly.
We have something? Yes, no?
Yes.
All right. Where is D prime at?
4, 5.
4, 5.
Oh, forget that.
Should be at 4, 5. Positive 4, positive 5. Okay. Where is E prime at?
2, negative
2, negative 3. Okay, so if we have our points, we could go ahead and connect to have our figure. Okay, what do you notice about the ordered pairs here? What changed?
D and E.
D and E, okay.
Yes.
What changed on D and E?
the quadrants.
What about the quadrants?
The -4.
They are
The -4 became a positive 4.
And the -2 became a positive.
And the -2 became a positive 2. So, when we reflect over the y-axis, the x values change. Okay? So if we reflect over the x, the y value changes, and when we reflect over the y, the x value changes. The c remained the same because it was on the line of reflection. All right, the reflection rule. The x value becomes opposite. So here, this is going to be negative x, positive y, or opposite x, positive y, or opposite x, whatever y is. It doesn't have to be positive. Okay? So this is going to be for the y-axis. Okay? There is one more scenario that we may see. Okay? With this page protector or the patty paper like we used last week helps us out a lot with this. So it says reflect triangle XYZ over the line y is equal to x. So that y is equal to x line is this right here. Okay? So what I want you to do is on your page protector, you are going to take your page protector, you're going to trace the x-axis, the y-axis, y is equal to x, and your points. Okay? So you are tracing over all of that stuff. So x-axis, y-axis, the line y is equal to x, and the points x, y, and z. Can anybody look at this and tell me what point will not change?
Z.
Z. Why?
Because it's on the XY axis.
It's on the line of what?
Reflect.
Reflection. That's why it does not change. So if I traced over my x, traced over my y, traced over y is equal to x, And then I'm gonna put my points of Z, Y, and X. Okay? When I flip my paper, so I have it here, right? When I flip, what I'm actually doing is I'm going up like this. Do we see that?
But
So I'm actually flipping my paper to go over that Y is equal to X line. So if I took the paper, I would line up my axis, which now my Y axis is actually my X axis, and my X axis is actually my Y axis. That's what actually happens. And then I am over here where my Y is in quadrant 2 and my X is in quadrant 1. So X is going to be, X prime is what? 1 and
1 and 4.
1 and 4. Okay. What is the Y?
-3 and 2.
Is -3 and +2.
Oh, both change.
And we said that Z would be -2 and -2. So question here. If I look at my ordered pairs, what is actually happening?
Both become opposite.
But are they becoming opposite?
Yes.
Yeah.
No, because negative.
No, because when we were talking about opposites before, so it was what was happening? They were changing from positive to negatives.
They're switching spells.
They're switching what?
The Y's becoming the X and the X's.
The Y's are becoming the X's and the X's are becoming the Y's. That's what's happening. Okay? The X's are becoming the Y's and the Y's are becoming the X's. Sorry for that red line that's going across, y'all.
Will it still
Okay.
be the same?
So, the what? Will what?
Will it still be the same if I like use the other formula they use? Like if it's like in the, I don't know what it's called, the line thing?
I'm not following what you're trying to ask.
I don't know how to explain it.
Okay? The X and Y coordinates change places. So what's happening is Y is going in the X spot and X is going in the Y spot. The Y's and the X's are switching places. Okay, this was Z prime. This is X prime. And this is Y prime. So that is what your new figure should look like. Okay? Any questions for that? All right, let's go ahead and look at number 4. Okay, let's look at number 4. Not sure how to get this on. Okay? All right. Let's look at number 4 now. Go ahead and graph triangle XYZ with vertices -6, -6, Y -2, 1, and Z 2, -2, -6. Okay? So X is going to be -6, -6. Y is -2, -1. And Z is -2, -6.
Isn't this the same exact problem that we had yesterday?
It might have been. All right. Graph the image of triangle XYZ after a reflection over the Y-axis. All right. So, either get your page protector out and trace XY axis, trace points X, Y, and Z, and actually flip it over. What axis am I flipping over? the y-axis, so I'm gonna go ahead and highlight. Or count, or if you know the rule,
I know.
you can do it either way.
So like if you're looking at it and it's 2 on the left quadrant, on the third quadrant, when you would flip it, it would be 2 on the right, and it would go down, and then so it'd be like 2, -2 for y.
Not -2.
X and Z will still be negative.
What quadrant are you gonna put the entire figure in?
4.
4. The entire figure is going in 4, okay? So that we know, right? Because I'm flipping over the y-axis.
So that's
So
Z.
what's changing?
The Y.
The axis.
Not the y,
The quadrant.
x value is changing. Okay, x value changes. So instead of -6, x is going to be what?
6.
Positive 6, -6. That's if we wanted to do it with points.
Yeah, and so then Z would be +2, -6.
Yes.
Yeah.
And what is y prime, since that's the only one we have left?
2, -2.
Not -2.
1.
-1.
Oh.
Okay. So, if you can't remember those rules, that page protector will always give you a right answer.
Wait, but what about the other one? Can I explain it on the board? 'Cause I was,
One second, let's finish this question. What type of triangle is XYZ? Right, a right triangle. What is the length of side XZ?
Like 4, 5.
5.
Well, let's count this. 1, 2, 3, 4.
Oh,
It is 4 units.
I was thinking Z and Y.
Technically, that'd be.
What is the length of X prime, Z prime? 1, 2, 3, 4. This is also 4 units. What is the relationship between XZ and X prime, Z prime?
Like 6.
Congruent.
Congruent or what?
same size.
Equal. What is the relationship between triangle XYZ and triangle X prime, Y prime, Z prime?
Congruent.
Congruent. Remember, translations, reflections, and rotations create congruent figures. Okay, congruent figures.
Technically, that's 3 1/2 of a unit.